You've heard the term trampoline functions. A trampoline function is a small piece of code that indirectly transfers control to another function. It serves as an intermediary or jump point to redirect execution flow, often used for implementing advanced programming techniques, optimizing code execution, or mitigating vulnerabilities. A trampoline function is typically a simple function or instruction sequence that redirects execution flow to a target function or address, performs any necessary setup or teardown before or after the redirection, and returns control to the caller, which is optional depending on the implementation. Trampoline functions are applied in a few ways. You have mitigating speculative execution vulnerabilities. Retpolines are return trampolines. Retpolines use trampoline functions to prevent speculative execution attacks, like Spectre Variant 2. When a program encounters an indirect branch, it jumps to the trampoline function instead of directly executing the branch target. The trampoline safely directs execution to the intended target, preventing branch prediction exploitation. Then you have callback mechanisms. Trampoline functions are often used in programming environments where a callback function must adhere to a specific signature or calling convention. For example, in dynamic languages or virtual machines, trampoline functions adjust function arguments or environment details before calling the target function. Then there is dynamic code generation. Trampoline functions enable dynamically generated or runtime injected code to integrate with statically compiled code. For example, just-in-time compilation, JIT compilation, often uses trampoline functions to bridge between precompiled code and dynamically generated code segments. It's also used for lazy loading or initialization. Trampolines are used to defer the execution of a function until it's actually needed. They perform initialization or set up the first time the function is called, then redirect subsequent calls to the actual implementation. They're also used for tail call optimization in functional programming or recursion-heavy applications. Trampolines can optimize recursive calls by reusing stack frames, preventing stack overflow. A trampoline repeatedly invokes a function until the computation completes. They're also used for FFI, foreign function interfaces. In multilingual programming environments, trampolines allow functions in one language to call functions in another while adhering to calling conventions. You can take a look at the trampoline functions versus normal functions chart. So the key example of trampolines and retpolines, mitigating Spectre Variant 2. An indirect branch is replaced with a call to a trampoline function. The trampoline traps speculative execution in a safe loop. When the actual branch target is resolved, the trampoline function redirects execution. Trampoline functions provide flexibility, allowing dynamic redirection and runtime decision-making. They provide security, protecting against speculative execution vulnerabilities, and they provide optimization, improving recursion and function integration in complex systems. There are disadvantages, though, of overhead. Additional jumps may introduce latency and complexity as they require careful design to avoid performance bottlenecks, and maintenance as these can make debugging and tracing execution more difficult. Trampoline functions are versatile tools in programming and CPU execution flows, widely used in areas ranging from security mitigations to runtime optimization. They act as a critical intermediary in scenarios where control flow must be managed dynamically, safely, and efficiently.